Research is also important because we want to know the exact mechanisms between the gene defect and why it's giving those clinical features of arterial tortuosity and arterial aneurysms. And so that is something that is often difficult just to do on either blood samples or some biopsies. It may help, but one of the most important things is to have a valuable animal model for that. And so what we initially started with is making a mouse model, an existing mice model. However, it turned out that the mice didn't show any particular phenotype that could be linked to ATS. There was no tortuosity, there were no stenoses, there were no aneurysm formations. So we had to take another approach. So we made a double knockout mouse model that also knocked out the gene that is responsible for making vitamin C. Because there is a huge difference between humans and mice, and that mice can make their own vitamin C while humans can't. And so we made this double knockout model because gluten is actually expected not to be a glucose transporter, but a vitamin C transporter. And so our initial data might be suggestive that there are some mild arterial abnormalities, but still nothing compared to what we see in patients. So the next level we will go to is actually making a zebrafish model and see if those fish may actually show clear anomalies that can be related to ATS. Once we have such a model, we have access to all kinds of tissues: arterial tissue, heart tissue, skin tissue, muscle tissue, and so forth. So this would be truly valuable to study the mechanisms in detail and find the exact connection between the gene defect and the clinical presentation. And having those connections, this will lead to opportunities to try and do some compound screening in order to find medications that might be helpful. Actually, when I started my PhD, Paul was one of my supervisors. And so he already had the region on the chromosome where the gene was expected to reside. And so I started screening all those genes, which was indeed a very difficult task because it was quite unexpected to find mutations in that specific gluten gene. And so that actually caught my interest. Meanwhile, I was doing clinics on connective tissue disorders in general. And so I got in touch with patients with ATS, but also with other connective tissue disorders. And that actually caught my interest because these patients are facing amazing problems and we don't have answers yet to those problems. So that's something of our goals that have been set forth, that we want to find better treatments, better management guidelines in order to help those patients. And also we could look into more features in the carriers, and as it seems now, there seems to be some mild features in carriers that do not relate to any arterial tortuosity, but that may at least cause some skin problems or some mild vascular problems. And so future research will actually show us, or will be able to confirm whether these findings are correct. Yes. And it was really exciting to hear about a patient organization and a nonprofit that would actually work on gathering patients, to bring them together, to be able to phenotype them in detail, and to be able to actually do clinical examinations on all these patients. We have about 100 families worldwide, and they are dispersed all over the world. So actually, if you need to see patients, you would travel from country to country. And so this was a great opportunity for me to come to the United States and see almost 10 patients at once. it was really a great honor for me to be asked to become the medical director of A Twist of Fate. Because, however, I still haven't seen that many patients, maybe 25 or 30 throughout my whole career, but still I have studied a lot of medical files of patients that I might not have seen in real life, but still it gives you further knowledge about the disease and how you have to manage it, how you have to follow the patients. And so, in my position as a medical director, I think it's a privileged position actually to bring that message to patients and to their physicians. Okay. So actually one of the most important goals we have to do is actually centralize all clinical data, because this will tell us how we have to manage and follow up patients with this disease. And so it's important that we can bring all physicians together. So we need to build a team of physicians that are acquainted to look for these patients. And so this is one of the beautiful sides of this collaboration between the nonprofit and between our research team. Again, we have a clinical team that has a vast experience in management of patients with connective tissue disorders. And so we have adult cardiologists involved, we have pediatric cardiologists, we have pneumologists, we have dermatologists, we have physiotherapists. So that makes up a great team from the clinic, so we can perform deep phenotyping. On the other hand, we also have a strong research team back in the lab, and so we have Paul and Andy who are supervising a lot of work on the research efforts on ATS, but we also have young people, PhD students, that are committed every day to work with these animal models in order to find out the exact mechanisms how these molecular defects would lead to a certain disease. Yes, well, that was actually one of the beautiful things of these clinics, to see these patients interacting with each other, interacting with physicians, interacting with researchers. And it increases your commitment to the disease, because actually you can put faces on patients, you can put a face on a disease, and so you actually can see what they are coping with during daily life, and that's really motivating and also really rewarding to see that your job is actually important, what you do. Similar defects in the same gene actually causes quite a wide variety of clinical symptoms. And so that's also one of the mechanisms we want to study. Why is it that a similar defect causes still quite a variable clinical phenotype? This might have to do with genetic background, this might have to do with environmental changes. We don't know actually. And so having animal models would also be very beneficial to study this. I actually had to step in a new world when I joined the nonprofit. It's another way of thinking, because from a research point of view, you actually want to gather samples and you want to start and find out the mechanisms. But of course, in a nonprofit, first of all, what is most important is the clinical care for patients and bringing patients together. Giving them support, giving them opportunities to learn from each other. And so this is also a very important aspect of managing patients that usually as a researcher you don't always experience in that way. So this is truly rewarding for me to be able to help with this and try and find money for these to make this possible. So parents may actually be very desperate the moment they learn that their child has arterial tortuosity syndrome. However, if we look now compared to 10 years ago, we already know better what the disease is actually like and what the risks are. And we can follow those patients. We also know that we can do surgery on patients. So we are advancing just by collaborating and putting information of all patients together. And with our further research efforts, I truly think that within the next years there will be new opportunities for therapy to be able to prevent severe arterial issues to happen in these patients. And really that is the most rewarding thing you can think of as a clinician and also as a researcher. So as a clinician, you're of course very concerned about your patients, and through this collaboration between our clinic, the clinic in the United States and a twist of fate, we can gather all this information, we can inform patients about their management, and we can tell them if any complications are actually happening. And we can provide treatment for those complications. So this is actually the most rewarding thing you can think of, both as a researcher, as a clinician.